In section 1-2, we're going to be learning types of angles and some angle pairs, using, again, a bunch of vocabulary words, and we're going to learn a few parts of a circle. So we're going to start by, you can do this this problem if you want. I'll show answers in just a minute, but we're going to jump over here and get some vocabulary done. So when I see this page without even looking, it tells you to compare and contrast. You can do that. I'm going to jump straight to, I mean, you have to understand that we are moving so fast um, through this summer school program. There is no way we can do everything that Springboard wants us to do. So oftentimes I'm not going to follow the directions right here and make a compare and contrast list simply because I don't have time. I've got to tell you the vocabulary words that you need, and we got to move on. So you're welcome to make a compare and contrast list. I'm not going to. So when I see this list or this group of pictures, these are the vocabulary words that pop into mind. The first one is angles that are adjacent. And the definition of adjacent, I'm sure you can look it up in the back of your book. I'm not going to write it down. You can look it up. These angles right here are adjacent. Why are they adjacent? Because they share a common endpoint. There's the endpoint right there for both angle. Angle 1 falls between these two rays, and angle 2 is made up of these two rays. So they share that common endpoint right there. And they also share a ray. So this ray right here makes up angle 1, and this ray right here helps make up angle 2. Now, what they do not share is they do not share any interior points. So if I were to go up here and put in a bunch of red dots up here, all of those red dots lie on the interior of angle 1. And if I change color, let's make it blue, and I put a bunch of blue dots over here, all of these blue dots make up the interior of angle 2. And there's never a place where angle 1, the dots in angle 1, and the dots that are in angle 2, they don't ever share a space. They're two completely different spaces. So adjacent angles have to have a common endpoint. They have to have a common edge or a common ray, and they can't share any interior points. So angle 1 and angle 2 are adjacent. All right, I'm going to explain to you. You may be thinking, well, they're never going to share. Well, I could if I was talking about angle. Let's see if I'm talking about angle. See, this is where I'm going to add. Let's see, I'm talking about angle 1, and I want to talk about angle ADC. Okay, angle 1, I'll make the interior dots, some dots on the interior of angle 1. I'll make those blue. Now, angle A, oh, and by the way, they share a common side. Here's a leg they share. AD right here. AD makes up angle 1, and AD also makes up angle ADC. So there's the side that they share. They both have the common vertex D. D down here is the common vertex. Angle 1 could be called angle ADB. Okay, so D is the vertex of angle 1, and D is the vertex of angle ADC. Now, if I go up here and change my color, let's see, I need something that's really going to stand out. Let's do orange. We'll do orange right here. Okay, and I want to shade the interior points of angle ADC. Okay, well, here are all of the interior points of ADC. And so you can see that there's this section right in here where we have both blue dots and orange dots, okay? So that means that even though angle 1 and angle ADC have a common endpoint and they share a common side, these are not considered adjacent angles. Now, I'm going to erase this stuff. Don't worry. Remember, this is a video, so you can always go back and look at it again. But I'm going to erase this stuff because I don't want you to think that there's not a pair of adjacent angles here, because there certainly are. It must be slow erasing. It's probably going to freeze. Maybe not. Well, it's not doing anything anymore. So, the two angles that are actually, yeah, it's frozen. I did too much for it all at once. It's still thinking. There are adjacent angles here, and the angles that are adjacent are angle ADB, which is this angle right here, and angle, okay, it's caught up with me now. Maybe I can finish erasing. It just doesn't want to erase anymore. All right, so since it doesn't want to erase, I'll go back and do. So we've got this angle right here, angle 1 and angle 2. Okay, angle 1 is all of this right here, and then angle 2 is all of this right here. They share a common endpoint, and they share this side right here, side BD, but they don't share any interior points. So we could say that even though these two were not adjacent, angle ADB and angle BDC are adjacent. Okay, so they got to be touching each other to be adjacent. Are these two angles adjacent? No. Are these two angles adjacent? No. Okay, the next word is complementary. And if you look in your book over here, they give you these two definitions. I don't know if this is the first time. It says recall. So I'm assuming that at some point or another you learned about complementary and supplementary angles. If not, then I'm introducing it to you right now for the first time. Complementary are angles that add together to be 90 degrees. They have a sum of 90. Complementary angles have a sum of 90. Supplementary angles have a sum of 180. So these two angles over here, and this is another vocabulary word. Do you remember the vocabulary words acute, obtuse, and right? What about straight? Okay. Those are all ways to identify an angle. So angle 1 up here is acute. This one is acute. Angle 2 over here is obtuse. And we don't have letters. But did anybody see the big angle? If we put them together, we get a straight angle. Maybe I'll name it in a minute. Angle. How many angles do we have right here? We have angle ADC, and we have angle ADB, and we have angle BDC. There's 3 angles there. So angle ADC, remember that little mark right there? That means this is a right angle. This one, these two right here would both be acute. Okay. But because we can add these two up and we see that it ends up equaling 90 degrees, then we say that these two angles right here are complementary. My notes are a hot mess. Hope you're doing a better job than me. Angle ADB and angle BDC, those two make a complementary pair. These two right here are complementary. It's a complementary pair. Why? Because if you add them together, you get 90 degrees. Students often forget that the definition of complementary does not say they have to be adjacent. So you do not have to have adjacent angles in order to have complementary angles. They simply have to add together to be 90 degrees. Now, often we do deal with them that are adjacent, but that doesn't mean that they have to. So these two right here, supplementary, they add together to be 180. 30 plus 150, so these are a supplementary pair. Now, there's also another supplementary pair up here. They are adjacent, and they add together to give you a straight angle. They didn't label this one for us, but if we call this A, B, C, D, then we'd see right here that angle ABD, okay, we start with ray BA, and then we swish it around until we get to angle BD. We rotate it around. Then we end up with angle ABD. That's a straight angle, okay? And straight angles equal 180 degrees. They have 180 degrees in them. So because we have adjacent and supplementary, we call it a linear pair. Adjacent and supplementary, then we call that a linear pair. Okay, so lots of vocabulary word: acute, obtuse, right, straight, supplementary, complementary, adjacent, and linear pair. All of those vocabulary words need to be at the tip of your tongue. Okay, I mean, it needs to be, oh, you look and recognize. Okay, so the one that's missed the most, this one right here, I don't know what happens to poor linear pair, but linear pair is the one that gets left off the most. And you'll need that whenever we do our brief lesson on proofs, because linear pair, being a linear pair, is something that you can tell by looking at something. So you need to be sure you know that definition. All right, I'm going to stop the video, so let that absorb.